Yes. So what exactly are the marginal concepts and what is meant by marginal concept? Marginal concept relate to change in the total. That is, like we have the marginal utility is the change in the total utility due to the change in the consumption. So we have the marginal utility. It measures in the change in the total utility, the change in the total utility due to the change in the consumption of, let us suppose, good act. Likewise, so we can say marginal concepts refer to change, and finding of the marginal function from total function is basically a measurement of change. Now, what is the tool? Tool to find out this change, we call that derivative. So we have different kinds of marginal concepts. So first is the marginal utility. So we have the marginal utility, marginal utility. Now what is marginal utility? Marginal utility is addition made to the total utility by consuming one more unit of a commodity. That is marginal utility. Marginal utility is addition made to total utility by consuming one more unit of a commodity. Okay, so the formula we use for measuring the marginal utility, that is marginal utility is equal to the total utility derived from consuming n n units of a commodity minus the total utility consumed, total utility derived by consuming n minus 1 units of a commodity. Okay, so supposedly, let us say let us say 4 units of good X give us a total utility of 10, and 5, or let us say 5 units of good X gives us 12 units of utility. Then we can say marginal utility or total utility derived by consuming fifth unit of good X will be equal to the total utility derived by consuming 5 units of good X minus the total utility derived by consuming 4 units. So this is the total utility when we consume 4 units of good X. This is the total utility when we consume 5 units of good X. So in this case, I request all you, please share this video and this channel with your friends. There is the only motivation for me to make more useful stuff for you people. Okay, so the persons who are live, they can share this channel, because I make these videos free of cost. I don't charge a single penny for these questions, rather the concepts. I take the questions you ask me, and I answer those questions on this YouTube channel. So here you can see now, total utility derived by consuming 5 units is 12 minus total utility derived by consuming 4 units of good X, which is 10. That means the marginal utility. So let me write it here. Marginal utility by consuming fifth unit will be equal to 12 minus 10, which is equal to 2. Now how do we write it in the calculus? Let us take an example. Let us suppose for individual consuming more, or let's take any, if we are being given, let us suppose, let me write it in proper way. So marginal utility is equal to the change in the total utility due to the change in the consumption of good X. if we have good x in consideration. So total utility function for an individual. So this is for the when we consume one unit, that is good x. If we have two two commodities that the consumer is consuming, let us suppose utility derived by consuming good x and y. Okay, so let us suppose we have x square y plus xy. Okay, let us suppose this is our utility function. Now here what will we do? We need to find out the marginal utility of good x and marginal utility of good y. So marginal utility of good x will be the change in the utility, total utility, due to the change in the consumption of good x. Okay, that is the partial derivative of this utility function with respect to good x. Now derivative of x square is 2x, so we'll get 2x times y plus derivative of x in the second term is 1, so we are left with y only. So this is the marginal utility of good x, and likewise marginal utility of good y will be the change. So this denotes the partial derivative, that is change in the total utility due to the change in the consumption of good y. Okay, I don't know whether I have taken the utility function correctly, but this is how do we take the partials here. Okay, so this time differentiating with respect to y partially, derivative of y is 1, so we are left with x square plus derivative of y in the second term is 1, so we are left with x. So that will be the marginal utility of good y. Okay, so this is how do we calculate the marginal utility. Now we have the second concept, what we call, from the marginal concepts we have the marginal propensity to consume. So we have the marginal propensity to consume. So by this what we mean? So marginal propensity to consume measures change in, that is the change in consumption due to change in income of the consumer. Okay, and we have marginal propensity to consume is the first derivative, that is the first derivative of consumption function. Okay, so let us suppose we have the consumption function, and let me write it here. Let us suppose consumption is equal to 100 plus 0.6y. This is our consumption function. Okay, so what does this consumption function tell us? It tells us that consumption is the positive function of income. As income increases, consumption of the consumer increases. Now this 100 denotes the autonomous consumption, okay, when the level of income is 0. Okay, and y denotes the income. Now what will be the marginal propensity to consume? Marginal propensity to consume be equal to the change in the consumption due to the change in the income. That will be the derivative of this function with respect to y. Derivative of a constant is 0, so derivative of 100 is 0. Derivative of y is 1, so we are left with 0.6. So it tells us if income increases by 1% or by 1 unit, our consumption will increase by 0.6 units, consumption expenditure. Okay, now we have also the relationship between so we have some live comments. Manava active saying nostalgia back in 10 years ago. Adi Sharma, Meti Nong C just saying good job. So thanks, my dear friends. It is my pleasure if I am making myself, useful for the community of economics. especially for the mathematical economics. Okay, so let's take another concept, what we call the marginal propensity to save. So the relationship is, we know that, and I will not derive it here. One important thing is that the sum of marginal propensity to consume and marginal propensity to save, it is equal to 1. So here we can calculate the marginal propensity to save also. So marginal propensity to save will be equal to, transpose it here, 1 minus marginal propensity to consume, and in this case it will be 1 minus 0.6, that is 0.4. Okay, so we can calculate this also. Now let's take uh, another concept, that is called the marginal rate of substitution. Okay, so let me see if any marker is working. So what is MRS? So marginal rate of substitution. What does this tell us? Marginal rate of substitution is for consuming, or we can say it measures, and let me write it specifically. So marginal rate of substitution between two goods. Let us suppose we have two goods, X and Y. So marginal rate of substitution between two goods X and Y represents the rate, and let me write it here. So it represents the rate at which the consumer is what we call prepared or willing to exchange good X and Y. Okay, the rate it measures, or we can say the marginal rate of substitution between good X and Y is the amount of good Y, or it is the amount of good Y that the consumer is willing to give up to give up to get additional unit of good X that is being measured by the marginal rate of substitution. So it is simply marginal rate of substitution between two goods X and Y. It is actually the ratio of the marginal utilities of good X and marginal utility of good Y. Okay, and marginal utility of good X will be the change in the utility due to the change in the units of good X consumed. Likewise, marginal utility of good Y means the change in the total utility due to the change in the consumption of good Y. These are the partial derivatives here. Okay, so let us take an example. Let us suppose we have the utility function. Utility function is, let us suppose 12x plus y. Let us take a simple. If we are supposed to find out the marginal rate of substitution between good X and Y, and remember, marginal rate of substitution will have the negative sign, because if we are consuming one more unit of good X, we are sacrificing some units of good Y. Okay, so its slope will be, so on the graph it will look like this if we have this indifference curve. Okay, so it will be downward sloping and it will have downward slope. Okay, so we will not take the negative value here for the sake of simplicity, we know this thing. So if we have, yeah, if we want to find out the marginal rate of substitution between good x and y, it will be the ratio of the marginal utility of good x upon marginal utility of good y. Marginal utility of good x will be the change in the total utility due to the change in the consumption of good x. Likewise, marginal utility of good y will be the change in the total utility due to the change in the consumption of good y. So in this case specifically, we will have, so we need to take the partials this time. Okay, so that means we are taking the partial derivatives. The change in the total utility due to the change in the consumption of good x means the derivative of this function partially with respect to good x. Derivative of x is 1, so we are left with 12. Okay, and marginal utility of good y means the partial derivative of this function with respect to uh, variable y, so it will be 1, which will be equal to 12 here. Okay, so then we have another concept, what we call then we have the marginal rate of technical substitution. So we have the marginal rate of technical substitution. So this is it represents the amount of, and let us suppose we have two things here, labor and capital. Okay, so marginal rate of substitution, it is actually the isocount analysis. We use this for the isocounts. So marginal rate of technical substitution represents it it represents amount of one input, amount of one input the producer is willing to give up for additional unit of another input, another input. Okay, and so that, and let me write it here, so that producer remains on same isocount. Okay, if I draw, let us suppose we have labor on the horizontal axis, capital on the vertical axis. This is our isocount. Okay, so what does isocount tell us? It shows us different combinations of labor and capital employed in the production process to get a fixed level of output. How do we combine labor and capital to get the fixed or same units of output that is being shown by the isocount? And marginal rate of technical substitution between labor and capital, it shows how many units of input 1 we need to sacrifice for additional one another unit for additional unit of another input. Okay, so let's take an example. Let us suppose we have the production function. We have the output is equal to, our output is a function of that is 6L square plus 3LK plus 2K square. Let us suppose this is our production function. That is, output is a function of two goods, and let me write it here. Output is a function of two inputs, labor and capital, and they are related by this very thing. Now, marginal rate of technical substitution will be marginal rate of technical substitution between labor and capital will be the ratio of the marginal product of labor upon marginal product of capital. That will be the change in the total output due to the change in the units of labor employed. That will be marginal product of labor. And then we have marginal product of capital, that is the change in the total output due to the change in the units of capital employed. That will be the partial derivative of, so dq upon dl, this is a partial derivative of this function with respect to L. Derivative of L square is 2L, so we will get 2 into 6 is 12L, 12L plus derivative of L is here 1, so we are left with 3K divided by dq upon dk means the derivative with respect to k partially. So derivative of, since we are taking partials, the first term will be 0, derivative of k in the second term is 1, so we are left with 3L plus derivative of k square is 2k, so we got 2 into 2 is 4k. That will be our marginal rate of technical substitution between labor and capital. How many units of capital we need to sacrifice for one additional unit of labor, that is being shown by this marginal rate of technical substitution. Then we have another concept is what we call the marginal product. Okay, so let me rub this out. So we have the marginal product. So marginal product refers, if I write marginal product, it refers to the change in the total product due to change in the due to change in, or let me write it, due to change in additional unit. Okay, so the marginal product shows us the change in the total product due to the change in one more unit of output. So simply if we let us suppose we had the total product is, our total product is equal to, let us suppose we have a firm which produces two goods. Let us suppose we have x and y, and they are related by this x cube plus 5xy plus y square. Okay, so this is the total product. Then marginal product with respect to good x will be the change in the total product due to the change in the units of good x. That means how our total product will change if there is additional 1 unit change in the product of good x. If we produce x, 1 more unit of good x, how our total product will change. So this is the partial derivative of this function with respect to good x. So we have 3x square here plus derivative of x is 1, so this is 5y. We are taking partials. Likewise, we can find out marginal product of good y. There is a change in the total product due to the change in the units of good y. This time taking partial with respect to good y. Okay, so it will be 5x plus 2y. Then we have the total cost, rather marginal cost and total cost. So let's take the marginal cost. Marginal cost is simply the change in total cost due to the change in the additional unit of output due to producing, or due to change in the production of, to the change in the production of one more unit unit of output. Okay, if total cost, let us suppose total cost is a function of good, total cost is a function of producing good x, and it is related like this: x square minus 4xy. Let us suppose we are taking two goods here, plus y cube. Okay, so total cost is a function of two goods produced. So marginal cost of good x will be the change in the total cost due to the change in the production of good x. That is a partial derivative of this function with respect to good x. So derivative of x square is 2x plus derivative of x is 1, so we are left with 4y. Okay, that will be the marginal cost with respect to good x. If we have one, let us suppose cost is a function of output produced, that is q square plus 3q. Okay, then in case of single good, it will be marginal cost will be the change in the total cost due to the change in the units of output, one more unit of output produced. So this time the derivative of q square will be 2q, and derivative of q is 1, so we will get 3. So this is in case of single single output, when we are producing one output, and this is in case of if we are producing two units of output. Okay, then we have other concepts, what we call the marginal revenue. That will be the change in the total revenue due to the change in the output if we are producing one more unit of output. I hope we have only these concepts here in economics. So we have calculated, we have the marginal utility, marginal cost, marginal revenue, marginal rate of substitution, marginal rate of technical substitution between two goods. We have marginal propensity to consume, marginal propensity to save. Then we have I cannot remember any other things. So this was a gist of the marginal concepts in economics. So if you have any questions, or if you want to ask me any question regarding this channel, how I shall improve this channel, I am here to answer your queries. Now Naeem Khan is saying that acha hai, appreciable. Thank you, brother. So it's your feedback that motivates me to make more useful stuff for you people. So I guess, let me see if anyone is here. Okay, let's take so I really appreciate if you share this channel with your friends, subscribe. That's the only motivation for me to make more useful stuff for you people. Okay, so one question that is being told, how to find out the optimal consumption bundle given the utility function. So we are being given the utility function that is being, this is the question that is being asked. Utility function is xy. Okay, so price of good x is 1. Then what is price? The question is price of good y is 2, and we are being told that the income, and let me show it, income of the consumer is 12 units. We need to find out the utility maximizing bundle here. Okay, so this is the question I have received. So since this is the case of utility maximization, so our endeavor will be to maximize the utility of the consumer which is related by xy. So we have a consumer who consumes two goods, x and y. We want to maximize the utility of the consumer subject to the budget constraint that he will be facing. So budget constraint will be price of good x times the units of good x he will consume plus price of good y times the units of good y, and it should be equal to the income of the consumer. Okay, so since we need to find out the optimal consumption bundle, what we need to do here, we want to maximize the utility of the consumer subject to the budget constraint. Okay, so this question I got from you people. So let me show it on the graph also. Let us suppose we have good x on the horizontal axis, good y on the vertical axis. Okay, so we are being given the budget line up, and let's write the specific budget line that is being given us here. So price of good x is 1, so we can write 1 into x is x plus price of good y is 2, so we write 2y is equal to, so income of the consumer is 12. Okay, so we want to maximize the utility subject to the budget constraint, and let us take let us draw the budget constraint here. This is the budget constraint. With the given budget, consumers' endeavor is to get highest possible satisfaction. Okay, so he can be on this indifference curve. Okay, but still he will not be able to. Here he will not be getting the satisfaction required or maximum satisfaction. Then what will be his optimal point? Optimal point will lie at a point where the indifference curve and budget line are tangent to each other. So specifically at this point, the consumer will choose to, the optimal bundle of good x and y. So at this point, what condition is being satisfied? So let me write it here. So the condition that is satisfied at this point is that we have the marginal rate of substitution between good x and y. It should be equal to the ratio of the prices, price of x upon price of good y. Okay, here marginal rate of substitution at this, since if we have this indifference curve, so at any point, so this point, it shows us the slope of the indifference curve. So marginal rate of substitution shows us slope of indifference curve, and at tangency it should be equal to ratio of the prices. So ratio of the prices, it is rather the slope of budget line. Okay, having said that, so what is marginal rate of substitution? I have discussed it earlier. So it is simply the ratio of the marginal utility of good x and marginal utility of good y. नार लोग उस बैटरी रोज 12% कुछ नहीं करो यार. Okay, so let me rewind it. So we have marginal rate of substitution between good x and y is the ratio of the marginal utility of good x and y, and it should be equal to the ratio of the prices. Price of good x is 1 and price of good y is 2. Okay, having said that, so marginal utility of good x is the change in the utility due to the change in the consumption of good x. That is, these are the partial derivatives. However, total utility changes when we consume one extra unit of good x. So we take the partial derivative of this function with respect to good x. Likewise, rather this function. I was concerned about this budget constraint. So marginal utility of good y will be the change in the utility due to the change in the units of good y consumed, and it should be equal to the ratio of the prices. So let's take the partial with respect to good x. So derivative of x is 1, so we are left with y. Likewise, derivative of this function with respect to y, so derivative of y is 1, so we will be left with x, and it should be equal to 1 upon 2. Now do some cross multiplication. We will get x will be equal to 2 times y. Then we plug this value of x into the budget constraint. Since x is equal to 2y, in place of x we write 2y. So we have 2y plus 2y is equal to 12, or 4y is equal to 12. Dividing both sides by 4, y will be equal to 3. So consumer will consume 3 units of good x. And how many units of good y? Rather, 3 units of good y, and plug y is equal to 3 in this relation. So x will be equal to 2 times 3, which is equal to 6. So 6 units of good x, okay, to maximize his satisfaction. And the total utility derived will be equal to, so total utility will be equal to, at this point it will be, since we have this utility function x times y, so we have x times y, so x is 6 and y is 3, so he will get 18 utilities at this point. That's the maximum he can get with the given budget. So this was one of the question from you people. As you know, in winters there is shortage of the electricity here. So let me wind up this live session. Okay, so if you have any question regarding this channel, I can answer those questions regarding this channel, how this channel is making difference to your academics. Okay, I will be waiting because the battery is getting soon dead. Hariman Mishra, Mishra Bhai is saying thank you for your work. Thank you, brother. This is yeah, your feedback means a lot to me. Your feedback only motivates me to make more useful stuff for you people. Okay, by using the lambda it can be solved. Okay, so we can also solve it using the lambda. So let me so if we have the given utility function, I can recall u is equal to xy. So we want to maximize this subject to the budget constraint x plus, so price of good y was 2 and it is equal to, the income was 12, I guess. So what we can do here, if we want to use the lambda notation using the Lagrange's multiplier method, we can do one thing, that is first step is what we do, because my battery is going dead soon. So let me shorten this video. So first step is we set the constraint equal to 0. Now look at the markers are also getting dry. So we set, first thing is set constraint equal to 0. So we have 12 minus x minus 2y. Okay, then second step is multiply both sides by lambda. So if I multiply both sides by lambda, if I multiply RHS by lambda, it will become 0. Then we need to find out the form the Lagrange's function, that is formed by adding the utility function, what we call the objective function, with the resulting constant that we have formed, that's lambda times 12 minus x minus 2y. Now to find the what we call the optimal bundles of good x and y, what we need to do, we need to partially differentiate this function with respect to x, y and lambda and solve them simultaneously. So L subscript to x means the derivative of this function with respect to x. Derivative of x is 1, so we will be left with y. Derivative of x in the here it will be negative 1, so we have lambda times negative 1, so we will get negative lambda, and we set it equal to 0. As we know, the derivative of 12 and last term will be 0 because we are taking partial with respect to x. So which implies y is equal to lambda. Likewise, L subscript to y means the partial derivative with respect to y. Derivative of y is 1, so we are left with x minus derivative of y is 1, so we are left with minus 2 lambda. Sorry, we have minus 2 lambda, and we set it equal to 0, which implies x will be equal to 2 lambda. Likewise, we take the derivative with respect to lambda. So since we are taking partial with respect to lambda, derivative of the first term will be 0, derivative of lambda is 1, so we are left with 2l minus x minus 2y, and we set it equal to 0. Then let us suppose this equation first, this is equation second, and this is equation third. Dividing equation first by equation second gives us, we have y upon x is equal to lambda upon 2 lambda. Lambda gets cancelled, we are left with 1 upon 2, so we get again the same result what we got earlier. Y upon x is equal to 1 upon 2, or x is equal to 2y. Then we plug this value of x is equal to 2y into this function, third equation. So we have 12 minus, in place of x we have 2y, so we have 2y minus 2y is equal to 12, or we will get, sorry, it is equal to 0. Solving further, we will get 12 minus 4y is equal to 0, or 4y is equal to 12. Dividing both sides by 4, we will get y will be equal to 3, and x will be equal to, since x is equal to 2y, so x will be equal to 3 into 2, which is equal to 6. So this is how do we solve it using Lagrange's method. Okay, so I'm really sorry, my battery drying fastly. So see you in next session. Thank you. So I request you people, please share this channel with your friends, subscribe. That will be only motivation for me to make more useful stuff for you people. Okay, see you in next video.